In this lecture, you'll learn about the basic operation of routers and how they compare to switches. Routers route. That's why they're called routers. And what that means is that they can direct traffic between your different IP subnets. They're required to do that. To be able to route traffic from one IP subnet to another, you're going to need a router to be able to do that. So they route traffic between our different IP subnets. IP is at layer 3 of the OSI stack, so a router operates at layer 3 of the OSI model. Obviously, it has physical interfaces on there as well, so it's also operating at layer 1. It also needs to understand layer 2 addresses, so it also operates at layer 2 as well. And routers actually will normally be aware up to layer 7 for advanced functions as well. But when they're doing the job of routing between different IP subnets, they're operating at layer 3, so routers are termed as a layer 3 device. To compare them with switches, routers are layer 3 aware and can route traffic between different networks. Switches are layer 2 aware, they're not layer 3 aware, and can switch traffic between hosts on the local area network. Routers support many different types of interfaces, such as Ethernet, serial, ISDN, and ADSL. Switches will typically only support Ethernet interfaces. Switches will typically have a lot more ports than routers, and switches forward broadcast traffic. Routers don't forward broadcast traffic by default. So let's go back a slide. A couple of the things that I said there are that routers support many more different types of ports than switches, and they'll usually have less available ports than switches. So if you remember, we had a look at a Cisco Catalyst 2960 switch, which had 48 ports when we did the basics of switches. So it had 48 ports plus some uplinks on there, and they were all Ethernet ports. If you have a look at the picture here, this is a Cisco 2800 series router, and it's only got 2 built-in Ethernet ports. You see there's 4 ports there, but one of them is a console port and another one is an auxiliary port. So it only comes with 2 Ethernet ports compared to our 48 port switch that we had a look at earlier. But if you look to the right of those ports, you see that there are modular slots there. So we can buy different types of interfaces such as ADSL, Ethernet, etc., serial ports, and we can put them into the router. Okay, moving on, let's have a quick recap of switch operation. So in the diagram here, you can see we've got a building, we've got a couple of switches in there. All our hosts are on the 10.10.10.0/24 network. When that's the case, they can all communicate with each other through our switches. When they're all on the same IP subnet, there's no need to have a router there. But if one of those hosts had the IP address 10.10.11.10/24, it's now on a different IP subnet, and it's not going to be able to communicate with the other hosts on the 10.10.10 network if we only have switches there. It's in another layer 3 network, so we need a layer 3 device, our router, to be able to route traffic between those hosts. So we put a router into the infrastructure now. It's aware of the 10.10.10 and the 10.10.11 networks, and it's going to be able to route traffic between all the hosts on the network now. Okay, one other thing to tell you about here is that you can get advanced switches which are layer 3 aware and can route traffic between different IP subnets. When you get one of those layer 3 aware switches, it's known as a layer 3 switch. It still has a lot of characteristics that are similar to a normal switch though, in that it will typically only support Ethernet interfaces and it will usually have more ports than routers. So looking at our diagram again now, you see that we only have switches in the network infrastructure, but the switch at the bottom is a layer 3 switch, meaning it is layer 3 aware. It's aware of the 10.10.10 network and the 10.10.11 network, and it's able to route traffic between them. Now, you can actually do this on a Catalyst 2960 like you saw earlier. Again, way back in the day, layer 3 switches were expensive, but they've come down in price now. So it is very common to have layer 3 switches routing the traffic which is within the different subnets on your local area network. However, if your connection outside that campus, out to the wide area network, is using an interface type which is not Ethernet, then you would still require a normal traditional router for that traffic as well. Thanks for watching. If you want to get hands-on practice with Cisco networks for free, then you can download my 400-page CCNA Lab Guide, which you can see above my head right now. Also, check out the video about my CCNA course. It's the highest rated course online. Thanks.